binary, permutation, communication, and dominant matrices. So what is a binary matrix? A binary matrix has just ones and zeros as its elements. Here are some examples. You can see there's ones and zeros in all of these matrices. There's no other number. Permutation matrices. It's a square matrix, so it has to be a square, so 2 by 2, 3 by 3, 4 by 4, where there is a 1 in each row and column. So you can see here there's a 1 in this row and this row, and then rows here and columns here. Same here, same here. These never repeating, so you can see 1, 1, only 1, 1, 1, 1, 1, 1, 1, 1, and they're separate, so you're not getting them. An identity matrix, that's a special permutation matrix that has a 1 in each row and column. And what a permutation matrix can be used to rearrange the elements in another matrix. So in other words, we change the order. Here's an example. X is a column matrix TAR. P is a permutation matrix P, which equals 0, 0, 1, etc. Show that pre-multiplying X by P changes matrix X to matrix Y, which will equal RAT. Right. So pre-multiplying X by P. So we're going to find in part 1, we're actually going to find P times X. So P is 0, 0, 1, 0, 1, 0, 1, 0, 0. And now we're going to times it by the X. So what this does, because it's the 0 in the first and the second, the third letter, because remember it's going to be 0 times 0 plus 0 times T plus 0 times A plus 1 times R. It's going to be the R first. Then it's the second letter that's going to come first, because there's a 0 here and a 0 here, because remember now we're multiplying by the second row. So the second letter is going to be A, and then it's going to be the first letter that's going to come first, because there's 0 for the second and 0 for the third. So T, and that's how we get our RAT. Part 2, pre-multiplying X by P squared leaves the matrix X unchanged. So we need to square the P. So all we'll do on our calculators, put a squared there. When we square the P, we're actually going to get, I'll write it down here, P squared times X, and I say pre, so before it. P squared is going to be, I'll do it all in 1, 0, 0, 1, 0, 1, 0, 1, 0, 0. Square it times the TAR. What this gives us when we work it out gives us TAR again. Part B says what can be deduced about P squared from the results in A part 2. Because we go back to the original, that means P squared is the identity matrix. So it becomes P squared is actually 1, 0, 0, 0, 1, 0, 0, 0, 1. Keeps them in the same order. Identity matrix. Communication matrix. This is a square binary matrix. Binary means ones and zeros, in which the ones represent the links in the communication system. Here is example 2. Eva Wong, Yumi and Kim students who are staying in a backpackers hostel. Because they speak different languages, they can have problems communicating. The situation they have to deal with is that Eva speaks English only, Yumi speaks Japanese only, Kim speaks Korean only, and Wong speaks English, Japanese, and Korean. Conveniently, this information can be summarized in a network diagram as shown above. There we go. In this diagram, the arrow linking Eva and Wong indicates that they can communicate directly because they both speak English. Their task is to construct a communication matrix. A communication matrix is just a matrix that shows us how they link together. So here is the speaker, and here is the receiver, just to make sure we get it. So here is E, W, Y, and K, E, W, Y, and K, and we're going to do it. Now, E can only communicate with W, so I'm going to put a 1 there and zeros everywhere else. W can communicate with E, with Y, and with K. not with itself. So E with Y and K, not with itself. Y can communicate only with W, so there it is there, and nothing else. And K only with W. K only with W as well, so it's here and nothing else. So there is my matrix that signifies that network. One-step communication link. Now, one-step communication link is when someone can directly communicate with somebody else. Okay, so in this case, from the network diagram, that Eva, who speaks only English, cannot communicate directly with Yumi, who speaks only Japanese. So she can only communicate with someone who speaks the same language. A two-step communication link. An example is Eva can communicate with Yumi by sending a message via Wong, who speaks both English and Japanese. So there's someone in the middle. So it's a two-step communication. We don't have to work out the two-step communication. We can just square the original one-step communication, and that gives us the two-step communication. So squaring it. Of course, here we're just showing where it's timesing by itself. You don't need to do that in the calculator. You can just put the little squares. If you've got the matrix, you can just put the squared over there. And this gives us the two-step communication here. We have to be careful. There are redundant communication links. Now, what does it redundant mean? Well, the person, the sender, and the receiver, if they're the same person, that means it's redundant. There's no point trying to communicate with yourself. So they were the ones usually on the diagonal. So WW, YY, KK, etc. Right on the diagonal. They are the ones that are redundant in the first step. Okay. All of the non-zero elements in the leading diagonal communication matrix or its powers represent redundant meanings in the matrix. However, all the remaining non-zero elements represent meaning two-step communication. So here's the summary. We can get our total by adding our one-step and our two-step communication links. If we wanted more steps, like three-step communication, we can do cube the matrix. Four-step communication, we can do that matrix to the power of 4. Dominance is very similar. Okay, but it's not communicating with somebody, it's getting over the top, like playing a game and being more dominant in that game. So in many group situations, certain individuals are said to be dominant. For example, 5 players, Anna, Birgit, Kaz, Dee, and Emma, played in a round-robin tournament of tennis to see who was a dominant, that is the best player. Here are the results are as follows. There you go there. Anna defeated Kaz and died. Birgit defeated Anna, Kaz, and Emma. Kaz defeated Di. Di defeated Birgit. Emma defeated Anna, Kaz, and Di. Both Birgit and Anna and Emma had 3 wins each, so there was a tie. So who was the best player? One way of doing this is to calculate a dominance score for each player. So here are the one-step dominances in this row. Here are the two-step dominances in this row, exactly as we did the communication. We do it exactly the same way. And you can see we're just adding up the rows here. Okay, and adding up the rows there. Now we can see by adding the one and the two-step dominances together, so we get the total for all of them, and then we just add up the rows again. And you can see that B was a dominant player with 9 wins. So Birgit is a top-ranked player with a dominance score of 9. Eva, second with 7, Anna, Di, equal third with 4, and then Kaz is at the bottom ranked player with a total of 2. So that's just by adding step 1 and step 2. So let's do this. Example 3. 4 people A, B, C and D have been asked to form a committee to decide on the location of a new toxic waste dump. From previous experience, it is known that A influences the decisions of B and D, B influences the decision of C, C no one, D influences C and B. Use the graph to construct a dominant matrix that takes into account both one-step and two-step dominance. Okay, just going to make that. I'll try to make it a little bit smaller, but not big. So what I'll do is I'll do it over here. So D equals. Okay, we got A, B, C, and D. So A, B, C, and D. A, B, C, and D. Okay, we know that A can communicate with B and D only. B and D, nothing else. B communicates, you've got to look at the arrows, B communicates with C only and nothing else. C can communicate with no one. So we'll put all zeros there. D can communicate with B and C. B and C and nothing else. So there is our one-step communication. Okay. It tells us to do a two-step communications. All I'm going to do is square this on the calculator. 0, 1, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, and 0, 1, 1, 0, and I'm going to square it to get my two-step communication. So let's do this. This is a 4 by 4. 4, 4. Okay. 0, 1, 0, 1, 0, 0, 1, 0, all zeros, 0, double 1, and 0. Square it. Here's my answer. Okay, so let me just write that down. I get 0, 1, 2, 0, and then 0, 0, 0, 0, 0, 0, 0, 0, 0, and 0, 0, 1, 0. Okay. The total is adding these two up. Now again, you can do all this in the calculator. So when I do my total, which is D plus D squared, I'm only going to write the answer for you. I'm going to get 0, 2, 2, 1, 0, 0, 1, 0, all zeros here, and 0, 1, 2, 0. So this, if I add this up, I get 2, 4, 5. This is 1, that's 0, that is 3. So remember, this was A, B, C, D. So 5 is person A. Person A is the most influential person with a score of 5. The second person would be D, the third would be B, and C is last. Now the quickest way to do that on your calculator, you come back here, okay, is there's your, keep it at square, there's your B,